Well, here we are at Chapter 5, Section 5.2 on random variables. We're going to begin with an example. If you flip a coin 3 times, there are 2 times 2 times 2. There are 8 outcomes. Now let x be the number of heads that occur. So what are all of the possible values? So x could equal 0, so there are no heads. X could equal 1, so it could be the last one, the middle one, or the first one, etc. So these are the all 8 outcomes that I was talking about. So x could equal 0, 1, 2, or all 3 could be heads. Next, what are the probabilities associated with each case? So for the first one, when x equals 0, there's only 1 out of 8. Then 3 out of 8, then 3 out of 8, and then 1 out of 8. So what we've created over here on the right-hand side, that's called a probability distribution table. So there are discrete random variables that we're going to be using for x, and that is things that can be counted. So it could be the number of goals that a player made, it could be the number of shoes that the person owns, that could be things that you could count. Then continuous random variables are things that can be measured, like heights and weights and stuff like that. So chapter 5 is going to be dealing with discrete random variables. Chapter 6 with continuous random variables. Then from chapter 7 and on, we're going to have some of each. Some will be discrete, some will be continuous. Now, since discrete means that you can count them, then you could write down the total list of possible values for x. So if, for example, a basketball player attempted 20 shots throughout a game, x could equal 0 if the person didn't make any, 1, 2, all the way up to 20 if they made all 20 of their shots. But you can list all of them. And if you list all of the probabilities next to that, like we did in those previous tables, then that's a probability distribution table. So how about this one? Is it a probability distribution? Obviously, it is a table, so I'm allowed to leave that word off. Well, in order to be a probability distribution, there's just 2 things that we need to check. One is all of the probabilities need to be between 0 and 1. So you can't have anything negative and you can't have anything over 1, because that would mean there's over a 100% chance it could happen. That's not possible. So all of these, 1/3, 2/3, 1/3, all of that is between 0 and 1. So yes, it passes part 1. Part 2, when you add up all of the probabilities, it has to equal 1.0. In other words, when you add up all the possibilities, it has to equal 100%. You can't have less than 100%, can't have over 100%, it has to be exactly equal. Well, if you add up these fractions, you would actually get 4/3, or 1 1/3. So that, it fails. So this is not a probability distribution. Okay, now we are going to make one that is a probability distribution. So roll a pair of dice. So 6-sided dice, regular 6-sided dice. Since there are 2 dice, I think we talked about this before. Since there's 2 dice and they have 6 sides each, that means there's 36 possible outcomes. And here are the 36 possible outcomes. So you could get a 1 and a 1, they add up to 2. Or here are all the ways that you could get a 7. So next, let x be the sum of those 2 dice. What are the possible outcomes? So at the bottom of each column, then I let x be what those numbers add up to. 2, 3, 4, in the middle, 7. All the way up to over here, 6 plus 6 would add up to 12. Next, what are the probabilities? Well, in this, since there's 36 possible in total, all of these are going to be out of 36. So this is only one possibility out of 36. The next one, 2 possibilities out of 36. And then 3, 4. Right here, there's 1, 2, 3, 4, 5, 6 possibilities out of 36. And then it counts back down until the only way you can get a 12 is with a 6 and a 6. So now we've created a probability distribution table. Although usually they don't go horizontal like this, they are instead vertical. So there, now it's vertical. Okay, the next thing to do is we're going to find the mean. So in other words, what's the average? Well, with a table like this, what you do is, here's the formula. So notice that this symbol is the mean for the whole population because this is the whole population of scores for x. There's nothing else x can be if you're talking about two six-sided dice. So this is the mean for the whole population. And what you do is you take each x and multiply it with each probability. And at the end, you add them up. So we would just multiply 2 with 136 would be 236. Multiply 3 with 236 makes 636. And then this one would be 1236, 2036. And then, through the magic of math, I have all of them. So notice all I did was multiply across. This would be 3036, this would be 2236, and 1236. Now, do this part. The sigma part means add them up. And so, when you add them up, you can just leave the denominator 36. If you add up all the numerators, it's 252. 252 divided by 36 is 7. So the average is 7. So notice, for one thing, that's actually what shows up the most. The 7 shows up the most compared to the other ones. Also, the 7 is right in the middle. Take a look at this. If you look at the 6 and the 8, they both have the same chances of showing up. And if you took a 6 and an 8 and averaged them, guess what you get? You're right, a 7. Then you could pair up the 5, which is 4 out of 36, pair up the 5 with the 9. They both have 4 out of 36 chance, and if you average a 5 and a 9, the average is 7. So in many ways, it's true that the mean is 7. But you may remember our good old friend, the standard deviation. That's right, next we get to calculate the standard deviation. So we start over. Here's the table again, fresh. And the formula is, well, it's very similar. It's very similar to the last thing we did, except here you have to square the x's before you multiply with the px. So we're going to square the x's, then multiply with the probability, and then we'll do this part at the very end. So we're going to need a new column for the x squares times p of x. So that's going to go right here, and ready, go. There it is. So look, you just square this number is a 4. Multiply with this is 4 over 36. Square this number is a 9. 9 times 2 is 18, so 18 over 36. So this would be squared to 16. Multiply with this is 48, and that's where this one comes from. So then add up all of these numbers and then divide by 36. So it turns out to be a 1978 divided by 36. And I'm not going to get the decimal for that. I'm just going to put that right here in the formula. So the fraction 1978 over 36 goes right here. And then this is just going to be minus 7 squared. So you take the square root of the fraction minus 7 squared, and the standard deviation turns out to be 2.438. Well, now that we have the mean and the standard deviation, we can answer questions like this. Would it be considered unusual to roll a 4? You may recall the word unusual means we get to use the z-score. That's right. Remember the good old z-score? So you take the score minus the mean divided by the standard deviation. So for us, I'm asking about a 4, so that's going to be x. So it's going to be 4 minus the mean of 7 divided by that standard deviation that we just got, and z turns out to be negative 1.231. And do you remember what the rule is about z? If it's over 2 or below negative 2, then the original score is considered unusual. This negative 1.231 does not go past negative 2.0, so the answer is for nope, it's not that unusual. Another way to answer that question is you could go over here and just divide 3 divided by 36, and you'll see that 3 divided by 36 that is an 8.3% chance. So there's an 8.3% chance, which is not below 5%, so it's not considered unusual. Okay, we're now getting to the end of this section. The expected value. So you could be asked for the expected value. That's just a fancy way to ask for the mean. So here's a situation, and this is where companies hire mathematicians and statisticians to help them decide should they make this business decision or not. So they're going to invest $80,000 to develop some new product. 20% chance they're going to lose everything. 40% chance they're going to break even, and 40% chance they can make a $60,000 profit. What is the expected amount of profit? In other words, if you take these probabilities into consideration, are they going to be making money, losing money, or breaking even? Well, begin by letting x be the amount of profit, and we're supposed to find the mean. If we're going to find the mean, then we need the distribution table. So here it is. Now, this first possibility, since we're talking about profit, the first percentage of 20% talked about them losing everything. So that would be a negative $80,000. Ouch. Next, there's a 40% chance they break even. That's zero profit. And there's a 40% chance they make $60,000. So find the mean just means multiply straight across, multiply straight across, multiply straight across, and add up the results. And when you put all of that together, it turns out to be $8,000. So basically what that means is for each one of these products, or each time they did this, if they were to do this many times, they would make $8,000.